Hi, it's Miss Cat, and I'm here to talk about diffusion of liquids at different temperatures. So you've seen a demo of diffusion of food coloring through hot water and room temperature water or cold water. Will happen the same way, and we're going to talk about the science behind this and then draw some particle diagrams. The rate of diffusion depends on the state of the matter and the temperature of the medium. So in our hot and cold diffusion demo, our medium was the water. And so the rate depended on the fact that it was liquid water and the fact that we had hot and room temperature. Diffusion is going to occur faster for gases than liquids. And this is because the particles in a liquid are closer together than they are in a gas, causing more collisions. And that's collisions between our particles. This makes it more difficult for a particle to move in a liquid than a gas. And diffusion also depends on the temperature of the entire system. Okay, this is pretty important. This is because the temperature of a system increases, that's going to increase the speed of the particles moving in it. So when we talk about the medium, we're talking about whatever you are trying to mix your substance through. So in the hot and cold liquid, our temperature of the water and the state of the water mattered because that was our medium. In the smelly particles demo or simulation, our medium was the air, and so we're looking at the temperature and the state of the air, which is going to be gaseous. Okay, because of these speeds of particles, and the faster things go, the faster it's going to occur. This is going to happen. This diffusion is going to happen more rapidly at higher temperatures. Okay, so we're going to take a look at some particle diagrams. And what I have drawn already here in my boxes, we really only need 2 boxes. So I use my center box for the key. I've got a beaker representing hot water and cold water, and this is going to be the before and the after. I chose the same number of particles. I chose 10. That's going to allow me to show you what's really going on here. And then I'm going to use green for food coloring, and I'm going to just show the before, where I've got my food coloring kind of clumped together as the first drop that's put in there, and then I'm going to show the after at the end. So I'm going to go ahead and put my food coloring pieces in. I'm going to put 4 particles just because that's going to give us enough to show what's going on, but not too much to keep track of. So there's my 4 food coloring particles for before and after. Now we have to make sure that we show our particles are moving. And we're going to show that a couple of different ways. You can choose to use arrows on your particles, or you can choose to use movement lines or whooshy lines. Now, if you watch my video to show your diffusion of gases, you'll notice that I forgot to put these motion of particle lines on my particle diagram. So I've gone back in and drawn those lines on my particle diagrams to show that my particles of the gaseous smell particles were moving throughout the beginning, the middle, and the end. So take a second if you haven't done that and go ahead and put that on your particles. Okay, so with hot and cold, I want to show the fact that the hot particles are at higher temperature and moving faster while the cold is moving slower. I'm going to do this just for clarity, and for right now, you can choose the way to do it, but a good way to do this is to show 2 movement lines on your hot particles and 1 movement line on your cold particles. That's going to signify that those hot particles are moving faster. Now, I'm going to put these lines on my particles. Notice I'm showing these lines all different ways. They're pretty average in length. They're all a little bit different, okay, but that's showing that those particles are moving faster than if I were to put 1 line on each. Okay. Now again, you can use arrows here, but you do want to make sure that whatever method you choose, you've got a movement line on every single particle. Okay. Now, our food coloring particles, when they're first dropped in, are at the same temperature. they're room temperature, so I'm going to show a movement line of just one movement line slower on those particles. Okay, so what we observed with our macroscopic observations from the demo is that the food coloring spread a lot faster through the hot liquid than it did through the cold. So I'm going to show my 4 food coloring particles fully spread out throughout my water. Okay, again, I want to keep 4 particles in there. I want to show that my water is still hot. So I'm going to show 2 movement lines throughout here. Okay. And because we observed the fact that those food coloring particles moved quickly throughout that hot liquid, I also want to show faster movement on the food coloring particles. So I'm going to keep that consistent with 2 whooshy lines on my green food coloring particles. Okay. Now, the cold particles, or the cold liquid, those food coloring particles did not disperse quite as quickly. So I'm going to show that they are not fully mixed yet. Okay, so I've got those particles in the top of the beaker, but not having mixed all the way down to the bottom. And again, I want to show movement of all of my particles. I'm going to start with 1 whoosh line or movement line on my water particles. And then I'm going to add that, again, 1 whoosh line on each of my food coloring particles to show that those dispersed or diffused slower throughout that cold medium.